Welcome to next session. So here next problem. Determine the temperature distribution through the composite wall subjected to a convection heat loss on the right side surface with convection heat transfer coefficient as shown in the figure. The ambient temperature is -5 degrees Celsius. So they have given a composite wall. One end it is subjected to a temperature of 20 degrees Celsius. On another end it is subjected to a convection heat transfer coefficient, that is H is equal to 1000 watt per meter square degree Celsius, and they have given K1 is equal to 6 watt per meter degree Celsius and K2 is equal to 20 watt per meter degree Celsius. So K1 for element 1, K2 for element 2. On one side it is subjected to some ambient temperature. They have given -5 degrees Celsius. That is, on one side it is 20 degrees Celsius. On another side some ambient temperature, that is some surrounding temperature is there, that is -5 degrees Celsius. Now this is the question they have given. Now we are converting the given problem into FEM model. Since it has two elements, then we will get the three nodes: node 1, node 2, node 3. T1 at node 1, T2 at node 2, T3 at node 3. Therefore, 1, 2, 3. Then we will get T1, T2, T3. So 1 to 2 element 1, 2 to 3 element 2, then L1, L2. So this is the FEM model. Now first we are going to calculate the stiffness matrix for heat conduction. That is nothing but KE is equal to KA divided by L, 1 minus 1 minus 1 into 1. Now we are calculating stiffness matrix for element 1, stiffness matrix for element 2 based on conduction. Now for element 1, so K is nothing but 6. Area they are not given. We are concerned as assuming as 1 meter square divided by L is equal to 0.06 meter. Everything we are calculating in meters. Why they have given thermal conductivity and heat transfer in meter. So then we will get 1K matrix. Now this is for element 1. We are having element for T1, T2, or we can consider 1, no, 2. Therefore T1, T2, T1, T2. Next same thing we are calculating for element 2. Then we will get T2, T3, T2, T3. This is for K2. Now we are adding total conductivity matrix KE is equal to K1 plus K2. We are adding this K2 matrix and K1 matrix. Then we will get K1 plus K2 is equal to T1, T2, T3, T1, T2, T3. You now to add T1, T1. So we are going to see in both the matrix T1 is equal to 100. Here we don't have T1, therefore 100. Next T2, T1. So if you see this matrix T2, T1, we are having -100. If you see this matrix, we don't have T2, T1, then -100. T3, T1, here we don't have. Again in this matrix also we don't have. It is equal to 0. Like that. If you see T2, T2, if you see this matrix T2, T2, 100, T2, T2, 1000. Therefore 1000 plus 100, 1100. Like that we are going to add K1 and K2. So this is the total matrix, that is global matrix based on conductivity. Next same thing we are going to calculate stiffness matrix for the convection. Now if you see this problem, at this end it is subjected to surrounding temperature. So here they have given H is equal to 1000. Therefore at the end K end is equal to AH into 0001. Now since at the last node, therefore at the last node we are going to represent 1. So substitute A, substitute H. So calculate K matrix, total K matrix based upon the convection. Now we are having, then we are going to calculate the force matrix. The formula to calculate force matrix, since the temperature is that is this ambient temperature is acting at the last node only, therefore force matrix is AH T infinity 0, 1. Calculating the force matrix. Then we will, since the convection is acting at the element 2, in element 2 we are having node 2, node 3. Therefore here we will get T2, T3, T2, T3. Same thing for T2, T3. Now here we are having one global matrix. Again we are having another global matrix. This is based on convection. This is based on convection. Now we are going to add this K matrix and this K matrix. So therefore total K matrix plus K matrix, then we will get the total K matrix, and T1, T2, T3, that is equal to force matrix. Why here we are having T2, T3. Here we are having only 2 into 2 matrix, but here we are having 3 into 3 matrix. That's why we are writing the remaining as 0, 0, 0 in this total K matrix. Then we are going to add this matrix and this matrix. Then we will get the total global stiffness matrix. Therefore, K into T is equal to F. This is the force matrix. Now, in this problem, they given in the question at node 1, we know the temperature T1 is equal to 20 degrees Celsius. Therefore, eliminate T1. So, eliminating first row and first column, then we are going to calculate remaining temperature T2 and T3 on simplification. So, in this way, we are going to calculate the temperature T2 and T3, that is temperature distribution. So we'll get T2 is equal to 0.83 degrees Celsius and T3 is equal to minus 29196.83 Celsius. That is temperature is keep on decreasing from one end to the another end.